we're looking at our operations facilities, we try to make sure that what we're doing is fit for purpose within that building. So we're trying to incorporate the right products, the right fits, and right solutions. Geothermal chiller and heat pumps are operating year-round. So during the winter time, the heat pumps are connected to the geothermal loop, and the chiller is shut down because we don't need cooling during the winter months. Okay, and vice versa happens in the summertime. Now we have more than one chiller on site, though. Okay, so on the low load days, that one chiller may take care of the entire campus and our cooling demand. However, as the temperature outside increases, right, the number of chillers that we have to operate on site will also increase. So we have 272 wells that go down 300 feet into the ground. So each one of those is an individual bore down 300 feet, and we ran a pipe down 300 feet, back up 300 feet, and connected them all together. So it's one large closed loop system. In the summertime, that water inside those pipes is warmer than the ground, so the energy will transfer from the water through the pipe into the ground, and it'll continue to do that all summer long.
Throughout the cooler months, we're sending 36 to 55 degree water through the pipes in the ground, and that water is cooler than the ground, so we're actually pulling energy out of the ground and sending it back to the heat pumps we have here on site. Those heat pumps are using that energy to help generate hot water to offset part of our heating load throughout the campus.
So the impact for the campus is variable. So during a mild spring or fall day, our geothermal chiller could be doing 100% of our cooling load throughout the whole campus. During the dead of summer, when we're at kind of peak load, it'll be doing 20-25% of our load for the campus. During the heating season, that geothermal and the heat pump system will be doing about a third of our heating demand in the wintertime. Putting the PV on site was twofold. When we had the geothermal in place, we had a footprint on this 33-acre campus that we weren't necessarily going to construct buildings on top of, which lended itself very nicely to put photovoltaics on the ground on top of that geothermal system to use that space efficiently and effectively for something other than just parking or landscaping. So we were able to incorporate that array to generate 250 kilowatts of electrical energy to feed back into this campus. But that's just reducing our demand and helping to offset some of those emissions that are being produced or consumed by this campus. When we're looking at our operations facilities, we try to make sure that what we're doing is fit for purpose within that building. So we're trying to incorporate the right products, the right fits, and right solutions for that type of site, so that when our customers are able to come through and see what we're doing, it is a glimpse of what we are able to provide to them.